Okay, so you're welcome to this next lecture. So in the next one, I'm going to talk about math modeling versus word problems. Okay. So the last couple of lectures, we looked at what a mathematical model is, all right, and the different types of models. But we are honing in on mathematical or numerical models. Okay. So this will help us to gain a better insight into what mathematical modeling is or what a modeling program is. So consider this first question. We'll look at the second question later on. This first question says, suppose the population of your town, okay, is 20,000 and 35% of the citizens recycle their plastic water bottles. If each person uses 9 water bottles per week, how many bottles are recycled each week in your town? Okay, so if you like pause this video, think about a bit and see whether you can estimate that number, you can calculate that number. Okay, your town has a population of 20,000, 35% of the people in your town recycle their plastic water bottles. If in a week, each person recycles 9 water bottles, okay, how many bottles are recycled each week? That is in total, your town. Okay, so this is easy to calculate, all right? Take 35% of 20,000, all right? And 9 people recycle per week, so multiply by 9. So 35% of 20,000 times 9 bottles per week per person per week. And that gives you this amount, which is 3,000 bottles per week. Okay? So this is an example of a word problem. It's not a modeling problem. That's a word problem. Because the problem gives you explicitly, right? It gives you all the information you need to calculate this number. Okay? So all you have to do is determine the appropriate computations. Know that you just have to take 35% of this and multiply by 9, and then you get your answer. Okay? But the information you need is there. So that is different from this second question. This second question says this: how much plastic is recycled in your town? That's all you have. You want to determine how much plastic is recycled in your town. Okay, so this is quite different and a bit more challenging, right? This doesn't tell you anything about the population of your town, how many bottles are recycled per week, what the percentage of people who do that, nothing like that. This is just an open, right, question. Okay, so then you then ask yourself what information or data you need, right, to be able to help you answer this question. Okay, so the process of that you have to go through, right, to come up with some answer or an answer, right, then makes it a math modeling problem. Here, you don't have all the information, right? You just have this question, and you have to explore and research to be able to come up with an answer. Okay, so you might be thinking, yeah, you don't have enough information to answer the question. And that is the purpose, really. That is the point of a math modeling. Usually you don't have all the information, right? When trying to solve a real world problem, you don't have all of that. Okay, so it requires that you use, some knowledge of math and some creativity, all right, to be able to come up with some answers, all right? So in that case, we say that that question is open-ended, right? There are no specific, information given to you. So it's really an open-ended question. Okay, so mass modeling is actually perfect for open-ended problems because then you would have to piece, information from different places together to be able to come up with some answers. Okay. So it's possible that, that question came to your mind, how much, plastic bottles are recycled in your town, because you've seen maybe a lot of, plastic bottles lying around. You see a heap of them somewhere, and you are thinking, will these people recycle stuff? Okay, so it comes to your mind, but the way you come up with a solution is then a process, right? It's not a word problem. Okay, so mass modeling will allow you to use mathematics to analyze the situation and propose a solution, right? A solution, perhaps to promote, recycling. Okay, so before you can answer that question, you need to gather information, and the information you need is probably something similar to what you have in the word problem. What is the population of your town? How many people recycle water bottles? Should you consider all bottles or some types of bottles? All that, you have to gather that information yourself. Okay. Unlike the word problem where you are giving the percentages, the population, and all these numbers. Okay. For example, here you are told that the population of your town is 20,000. Well, is it actually 20,000 or that is an estimate? It's likely to be some estimate. Is it exactly 9 people, is it true that, each person in your town uses, 9 plastic water bottles per week? This number is probably an estimate. And so you have to do your own research, come up with these estimates, and then use that to estimate what you want. Okay. So usually you don't have that information. And so you have to go out and do research, either interviews, take some data, get some data somehow, and then come up with these numbers to help you answer the question. All right. So what you should notice is that the first word problem, all right, the first word problem doesn't really invite you to determine whether the scenario is realistic. It just just assumes that you will accept the information, the numbers given to you, right? You accept that that is true. And then you have to do the calculations and get the answer. It doesn't ask whether the 20,000 is true or not. It assumes that, yes, you assume that this is true, this is true, this is true. Using that, you compute it, right? It doesn't really invite you to question those numbers. But the second one required that, you have to do research and make your own reasonable assumptions and strategies for answering the question. Okay, the statement doesn't provide any specific details. So you have to get those for yourself. Okay, you would probably have to think about, okay, what are some other details that affect recycling? Would it be the position of recycling bins? How far are they from your house? What other factors will affect people from, recycling? So you would have to get that information for yourself. All right. The question doesn't tell what type of plastics that you need to take account of. You have to decide that. Okay, it's probably be difficult to quantify all plastics. So you have to think about the type of plastics that your study will gather so that, you put that in a nice framework. Okay, so mass modeling requires a lot of research. Research is key. Without the research, you will not gather the required information, the needed information that will help you to address the question you want to address. Okay, okay, so if after your research, you distill the original problem into something that is specific. So the question was that how much recycling is done in your town? That was the question. So you could rephrase it, right? And say, can you determine the volume of plastic waste in your town that is sent to landfills last year or the previous? Okay, so you can rephrase it to be something more specific that will help you to compute this volume, right? The amount of plastic. Okay, if you can rephrase it, then exactly the correct answer. Okay, but it's unlikely that you will ever have some sufficient information to find that answer. Okay, you will never have that. So you have to come up with a reasonable and clever ways to come up with good estimate. Okay, so given all of that, you would use that to develop a model, okay, that best estimates the answer, given the available information. Okay, so since no one really knows the true answer, if there was an answer there, if somebody had already done a study, you probably will not be doing that, right? So it's most likely that nobody has done a study about this. and you are the first person doing this. Okay. So your model is at least as important as the answer itself. Okay. As your ability to explain what your model is doing. Okay. So that is important. So in contrast to the word problems, we often use the phrase a solution as opposed to the solution when we talk about modeling problems. Because a modeling problem doesn't have the solution. There's no one particular solution, all right? Because the solution you provide when you do a modeling problem really is based on your estimates, based on the assumptions you made, okay? Somebody can come up with similar, a different solution, all right? Based on the amount of data they get at their estimates and their reasons they give to different things. But for word problems, you use the solution because there's only one solution. Okay. So this is because people, look at the same modeling problem. People who look at the same modeling problem may have different perspectives, right, into a resolution, and can certainly come up with different but valid alternative solutions. Okay. So if you like word problems, you can think of them as formal modeling problems. So somebody actually did their research and then they couched the question in the first one, right? The word problem. And that is how come you have the population of the town, 35% recycle, people use 9 water bottles and all of that. So somebody probably did the research already. So a word problem, if you like, was a former modeling problem. And now you would have to do your own research to be able to get those information to be able to rephrase or reword your modeling problem as a word problem. Okay? Okay, good. Now, mathematical modeling questions allow you to research real-world problems using your discoveries to create new knowledge. So that is one of the points, right? After you come up with your model, you have created new knowledge because somebody else can now use your model to either solve the same problem or use it in a different way to solve a different problem. Okay, so you have created new knowledge. So your creativity and how you think about the problem are both valuable. They're highly valuable in finding a solution to a modeling question. Okay, so that is why modeling is important. After you model it, you would think that your model you are actually using it to solve this particular problem, but it might end up actually being used to solve a different kind of problem, even though originally that wasn't the purpose. So that makes modeling quite interesting and fun, really. Okay. All right. So we spend a lot of time talking about math modeling versus word problem. It's important you get the difference. And hopefully what we talked about here about math modeling helps you to understand what goes on, right, before you actually come up with a model. All right. So I will end here. And then when I come back, we'll look at the modeling process. Okay, an overview of the modeling process. Okay, as I said, you can get very good information about these processes from the book, the reference book I talked about. All right. So that's when we come back, we'll talk about that. Right.